Hi students, so in this video I'm going to show you how to solve a problem involving a roller coaster car which travels along a track, and we have to find the velocity of this roller coaster at point B and at point C. So let me read the problem out to you. A roller coaster car with mass 200 kilograms is stationary at point A. Before rolling down the track, passing point B at the bottom of the curve here, and then continuing up to point C at the top of the next curve. Throughout its motion along the track, the roller coaster car has to overcome a frictional force of 200 newtons. Using the principle of conservation of energy, calculate the velocities at points B and C. Now, how do you go about solving this problem? Now, we have to solve this problem using the principle of conservation of energy. What this means is the total energy stored in a body over here will be the same at point A, B and C, which means the energy in any object is conserved. Now, energy can neither be created nor be destroyed. It can only be converted from one form to another. And in this case, my body over here, which has potential energy because it is placed at a height h, will be converted into kinetic energy as it rolls down. As it slides up again kinetic energy will be converted into form of potential energy and a bit of kinetic energy. Now before we start solving this problem, let's make a note of all the data that has been given to us. So mass of the car m equals to 200 kilograms, and height HA equals to 20 meters. Height HC is 10 meters. Height HB is 0 as it is at the ground level. What else do we have? The track length from A to B is 30 meters. From B to C, track length from B to C will be 20 meters. And that's about it. We have some more information here. It has to overcome a frictional force of 200 newtons. So frictional force which it has to overcome is 200 newton. Now always before solving a problem like this, it's a good habit to make a note of all the data that you have, and also make sure that you write the units against it so that you don't make a mistake while solving the problem. Now, by the principle of conservation of energy, the total energy in the system at point A is the same at point B and point C. In this case, the total energy at each stage is made up of gravitational potential energy, kinetic energy, and work done to overcome friction. So at this point here, it will have some sort of it will have a potential energy, kinetic energy, and some sort of energy to overcome the work done, overcome frictional work done. So what I can write here is energy total will be equal to EP at point A. Energy total will be equal to EP, gravitational potential energy, plus E, kinetic energy, plus work done to overcome friction. Now my potential energy is calculated as mass times gravity times height at point A, so it's height HA, plus kinetic energy is calculated as half mva squared, plus work done to overcome friction is calculated as force times distance that the roller coaster car has traveled, so that is S. And so we have written down the formula here, so we can do our calculations now. My mass m is 200, g is acceleration due to gravity, and g value is equal to 9.81 meters per second squared. So g is 9.81 times height HA, which is 20, that's the height, plus half mva squared. Now I'm going to write it down. Half m is 200, va here. Now at this point, at the point A, the roller coaster is stationary at point A, and hence my velocity is 0, plus the frictional force is 200 times the distance traveled by the roller coaster. Now at this point here, the roller coaster has not actually covered any distance, and hence the distance S is 0, because it is stationary over here and it is not actually moving. That is why this distance is 0. So I'm going to use my calculator to calculate this total. So that is going to be 200 times 9.81 times 20 plus 1 over 2 is half. This 2 will be equal to 0 because it is being multiplied by 0. VA is 0, S is 0, and this whole thing will be equal to 0. So I'm going to eliminate, not write it down in my calculator. And the total energy will be equal to 39,240. 240 joules. So that's the total energy that the roller coaster will have. Now using this total energy, we are going to find the velocity at point B and C. Now at point B, again the roller coaster will have some sort of kinetic energy, potential energy, and work done due to overcome friction. So at point B, again I'm going to use the same equation, E total. What I'm going to do is I'm going to highlight this equation here so that we know that we are using the same equation throughout. So E total will be equal to gravitational potential energy EP plus kinetic energy EK plus work done to overcome friction. Now at point B, again gravitational potential energy is M times G times H plus kinetic energy is half M. At this point here, the velocity will be VP squared plus work done due to friction is frictional force times distance. So my mass is again 200 kilograms, height HP. Now 200 times gravity is 9.81. HB value here is 0. So I'm going to write a 0 plus half Mass is again 200. Vb is an unknown quantity, so I'm going to leave it as it is. That is going to be the subject of my equation. Plus frictional force F is 200 Newton times S here is the distance traveled by the roller coaster. As it goes down, it covers a track length of 30 meters, and hence S value is 30. So this gives me an equation. So I'm going to continue writing down over here. E total is my known value, which is 39,240. Remember, energy is the same at the 3 points. That is why E total will be the same at all the 3 points. So I'm going to continue writing down over here now. 39,240 will be equal to, this here is going to equate to 0 because HB is 0, and hence 0, plus half times 200 is 100 VB squared, plus 200 times 30 is 6,000. 200 times 30 is 6,000, and hence now what I'm going to do is I'm going to use transposition, wherein I'll make VB my subject and find the value of VB. So VB will be equal to 39,240 minus 6,000. What I'm doing in this step is I'm getting the 6,000 on the other side of the equal to sign. So since it is positive, it goes on the other side as negative. Will be equals to 100 VB squared. Next step here, I'm going to get the 100 on the other side of the equal to sign, and because this is multiplied by now, it is going to go on the other side as divide. So 39,240 minus 6,000 over 100 will be equals to VB squared. And now I am going to get the square on the other side, and by the rules of transposition, when the square goes on the other side, it goes as under root of 39,240 minus 6,000 over 100, and I'm going to enter these numbers in my calculator. So square root of, top bracket is 39,240 minus 6,000, bottom bracket is 100, equal to 18.231. So always remember, write up to 2 decimal places. That is 18.23 meters per second, which are the units of velocity. It's going to be VB. I'm going to highlight my answer. Now we have just found the value of VB. Now we got to find the value of VC. Now I'm going to use the same principle again. So I'm going to use my same equation. E total at point C now. E total will be equals to E potential plus, that is gravitational potential energy at point C, plus kinetic energy at point C, plus my work done to overcome friction. Now again, E potential will be equals to mass times acceleration due to gravity times the height hc plus E kinetic will be equals to half mass times Vc squared plus work done to overcome friction will be F times. Now at this point here the roller coaster will cover track length AB plus track length BC. So times my track length AB plus track length BC, because it has to cover all this track, and here my track length AB, I wrote S there, which is again the distance. Track length is the distance that the roller coaster is covering. So now I'm going to enter the values which I have. Mass of the car is 200 times gravitation is 9.81 times height hc is 10 plus half into 100 pc squared plus frictional force is 200 Newton times track length AB is 30 plus track length BC is 20. That's going to be, now my E total is going to be the same. E total 39,240 joules. So 39,240. So again I have a bunch of numbers here and my VC is the subject that I have to calculate. So I'm going to write this again. 39,240 will be equal to 200 times 9.81 times 10, 19,620 plus half of, oh, I've written my mass wrong. My mass is 200. So half of 200 is 100 Vc squared. Please make sure that you don't make the mistake. This here is 100. Now please solve the problem as I solve the problem, so that you have notes written down. Plus 200 times open bracket 30 plus 20 close bracket equal to 10,000. So now I have to calculate Vc. So I'm going to write 100 Vc squared as it is, and I'm going to take all my numbers on the other side. So that is going to be equal to 39,240. 19,000, when it goes on the other side of the equal to sign, it goes as minus 620. 10,000, again as it goes on the other side, it goes as minus 10,000 will be equal to 100 Vc squared. So 39,240 minus 19,620 minus 10,000 will be equals to 9,620 . That's going to be equal to 100 Vc squared. Now when the 100 goes on the other side, it goes as divide, because here it is being multiplied by. So Vc squared will be 9620 divided by 100. We use the same rule again. Whenever you got 100, your decimal point shifts 2 places to the left. So VC squared will be equals to 96.20. Hence VC will be equal to under root of 96.20, because when square goes on the other side of the equal to sign, it goes as under root of over the entire number. So square root of 96.20 will be equals to 9.8081, and I'm going to round this up as 9.81 because the third digit is 8. So 9.81, and the units of velocity are meters per second. Now please don't confuse this 9.81 with the gravity. It's a complete coincidence that your VC value is 9.81 as well. So VC equals to 9.81 meters per second. So it's a good practice to highlight your answers. You had to calculate VC and VB. I'm going to keep this aside, and hence my problem is solved. So the velocity of the roller coaster at point VB will be 18.23 meters per second squared, and at point VC it's going to be 9.81 meters per second. Oh, this is 18.23 meters per second, not second squared, because it is velocity, not acceleration. Now what you do is watch this video again and you solve this problem exactly how I solved it, so you will have notes as well. And good luck.